Hi everybody, this is the video for Objective 6. So this is miscellaneous factoring. It's not a new kind of factoring, it's just that all of the factoring types are kind of mixed up all together in the questions. And so it's not a matter of learning a new type of factoring, it's a matter of learning how to identify what kind of a question it is that you're dealing with. And your handiest tool for that is going to be your factoring flowchart. So the first thing you need to do when you're looking at any factoring question is identify, do you have a greatest common factor? That is step one on your flowchart. You must ask yourself that question for every question you do. So if we look at this one, we have no coefficient on x squared, we have no variable on our third term, so there is no common factor here. So once we deal with the common factor question, then we jump to the second half of the flowchart. Is it a difference of squares? It is clearly not a difference of squares because we have three terms. Is it a perfect square? It is clearly not a perfect square because 35 is not a perfect square, and to be a perfect square, the first and the third terms have to be squares. So that leaves us with quadratic trinomials. So once you identify it, then you know how to factor it. And we factor quadratic trinomials with product and sum method. So product is equal to the last number here, which is 35. Sum is equal to the coefficient on the middle term, which is negative 12. So we're going to set up two sets of brackets. We're going to put an x in each, and then we're going to figure out the magical combination of numbers that multiply to give you positive 35 and add to give you negative 11. Because my product is positive, there are two choices. Either both numbers are positive or both numbers are negative. Because the sum is negative, I know that both of my numbers are negative. So what can I multiply together to give me 35? 1 and 35. I guess they would have to be negative 1 and negative 35. Clearly do not add up to negative 12. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5. Negative 5. Negative 7. Negative 5 plus negative 7, that is definitely negative 12. So into one bracket goes negative 5. Into the other bracket goes negative 7. Move on to the next question. Okay, start at the top of the flowchart. Is there a common factor here? We've got x cubed minus 16x. There definitely is because both of those terms have x's in them. So we start there. Take out the x as a common factor. What's left? X squared minus 16. Then you look at what's left in the brackets and ask yourself, can I keep going? Can I factor what's left? I have two terms. I only have one possible method of factoring if I have two terms, and it's difference of squares. So is this a difference of squares? So to be a difference of squares, you need two terms, which we've already established that this has, a minus sign in the middle, which this has, and both of the terms have to be squares, which they are. So inside the brackets is a difference of squares. So we keep our common factor, and then we factor the difference of squares. Two sets of brackets, square root the first, and that goes in each set of brackets. Square root the second, that goes in each set of brackets. One of the brackets gets a positive, one of the brackets gets a negative. Next question. Okay, so here we go. Negative 2xy minus 4x. So again, starting at the top of the flowchart, is there a common factor? That first term is negative, therefore there is at least a negative that I'm taking out as a common factor. But clearly on this one there's more. 2 and 4 share a factor of 2. And this term has an x and that term has an x. So the greatest common factor here is going to be negative 2x. Open set of brackets, what's left? From the first term is only y. Negative 2x times something needs to give me negative 4x. So a negative times the positive will give me the negative. 2 times 2 will give me the 4, and x times nothing will give me the x. So then you look at what's left inside the brackets and say, can I keep factoring? And the answer here on this one is no, because in order to keep factoring, something has to be squared. There has to be an x squared or a letter squared, and there's nothing squared in there. So that is as much factoring as we can do. On that one, we are only taking out the greatest common factor. Last question. Start with the greatest common factor. 25, 20, and 4. Anything in common? The answer is no. So then we go down into the bottom level of our flowchart. This has three terms, so we're looking at two choices. It's either going to be a difference of squares, it's either going to be a perfect square or it's going to be a quadratic trinomial. Quadratic trinomials, as far as we're concerned in grade 8 this year, means no coefficient on x squared. This has a coefficient on x squared. So chances are they're not going to give you a question that can't be factored at all. So chances are this is a perfect square. So we have to go through the process to check it. Does it have 3 terms? Yes. Are the first and the third terms perfect squares? 25 is, as is x squared, so that makes that entire term a perfect square. 4 is also a perfect square, so check that one. And then the last thing to verify is the second term. Does the second term meet the criteria for this to be a perfect square? So that would mean it has to be 2 times the square root of the first, which is 5x, and the square root of the third, which is 2. 2 times 5x times 2, that gives me 20x. Is that the middle term? Yes, it is. So therefore, this is a perfect square. So we're going to set a single set of brackets squared, and then we're going to take the square root of the first, which is 5x, square root of the third, which is 2, and the symbol from the middle is the plus. And there you have it. So that's the 4 kinds of factoring that we've learned. So this section has all the different questions mixed up, so you have to be able to use your flow chart. Hopefully you've committed most of it to memory by now. Use your flow chart to identify what kind of a question is it, and then factor it appropriately.